Setting up an in person meeting actually takes way more effort than most people realize. Here's how it goes usually. Your business associate suggests catching up in person. So you open up your calendar, look for some free time slots, and then send those options over. She then picks one that works and then say, where should we meet? Now you check your schedule again and realize that you'll be working from home that day. So the meeting spot needs to be somewhere nearby. You think of a nice outdoor cafe, maybe, sounds perfect. But then you remember it was pretty crowded the last time you went there. So you're not really sure about whether you'll get a table there. So now you either call them or check their website to see if the reservations are possible. And if they do not allow for reservation, you need to find a backup place. Only after all this back and forth, you do finally confirm the meeting. So as you can see here, the point is this whole process takes time and mental effort. And honestly, most people would rather focus on more important work. This is exactly where AI agents comes in. At each step, a specialized AI agent can think through the situation, gather the required information, and take the next action automatically. It can figure out the best time by connecting to your calendar and suggesting available slots. It can determine the meeting location by checking whether you are working from home or the office. If you're working from home, it can find nearby meeting spots and even consider your preferences like indoor versus outdoor sitting. It can check the weather forecast online. It can call the cafe using a voice enabled model and reserve a table. And once everything is confirmed, it can send the calendar invite and notify everyone. Notice the pattern here. The agent first thinks what needs to be done, that is reasoning. Then it performs the action, that is acting. This continuous cycle of reasoning and acting is why this framework is called ReAct. The model evaluates the situation, decides the best next step, and executes it. But what if the model did not follow this reasoning and acting loop? That is what we'll explore next. That is the next important framework is ReWOO, which stands for reasoning without observation. In simple terms, with ReWOO, we tell the agent to think through and plan everything in advance. It decides all the steps upfront without letting tool outputs influence its planning later. So once the plan is made, it sticks to it. Now let us compare this with ReAct using the same example that we discussed earlier. So with ReAct, the agent works step by step. It reasons about what to do next, uses a tool, looks at the output, answers the immediate question, and decides the next step based on that new information. For example, if the agent does not know where you are working from, it might check the HR Planner tool first, get that information, and then decide which cafe to check. This reasoning cycle keeps repeated throughout the process. With ReWOO, however, the approach is different. The agent first sits down and plans the entire sequence from the start to finish before taking any action. It does not pause midway to gather new information or change direction. So, in our example, in with ReWOO agent, it would first create a complete plan, check your calendar, confirm your work location using the HR planner, verify the cafe's availability, and even identify a backup option. Only after this full plan is ready does it begin execution, and it does follow the plan exactly as defined. One advantage of this is focus. For instance, if the cafe's website shows ad or special offer, a React agent might get distracted and spend time exploring irrelevant information. The ReWOO agent, however, on the other hand, it will ignore all that, and it says strictly on track. However, this also makes ReWOO less flexible. If something unexpected happens, like cafe being fully booked, the ReWOO agent cannot easily adjust because it is already committed to its original plan. So overall, React is more adaptive and flexible, while ReWOO is more structured and disciplined. Both approaches are useful, and the right choice really depends on the type of AI agent and the environment that it is operating in. Whenever we talk about AI agents, one of the first thing to figure out is whether we are dealing with a single agent system or multiple agents are working together. Let us focus on single agent systems first. These are much simpler to design, easier to manage, and honestly the best place to start when you want to build something clean and efficient without unnecessary complexity. Now, just because there's only one agent does not mean it is limited in any way. In fact, it can be extremely powerful. Every time you give that agent access to a new tool, its capability expand. It can do more, automate more, and solve more complex tasks. Another big advantage of using a single agent is that it makes things easier to evaluate, debug, and maintain. You don't have to worry about coordinating multiple agents on figuring out which one caused an issue. Think back to the example of a personal assistant that can reply to emails, book meeting rooms, and schedule meetings at the right time. Even though it is handling multiple tasks, it is just one agent using different tools. That's a classical example of a single agent AI system. This is the basic structure of a single agent system, and we'll break down each of this component and understand roles in few slides. But before that, it's important that we also understand the other side of the spectrum, that is multi-agent system. Now, when you're working in a team, you don't expect everyone to do everyone else's job, right? Let us say your company wants to redesign its website homepage. You typically have a graphic designer handling visuals, a copywriter working on text, a marketing specialist thinking about positioning, a brand manager ensuring consistency, and maybe an SEO expert optimizing for search. When each person focuses on specialty and collaborates properly, the final outcome is much better than one person trying to do everything. The same principle applies to AI agents as well. Instead of relying on one agent, you can have multiple specialized agents, each designed to handle a specific responsibility. Each agent brings its own strength, which makes the overall system more capable. But there's a trade off here. As you add more agents, the system becomes more complex to design, manage, and coordinate. To make this work effectively, you need orchestration, basically, a way to organize how agents collaborate within the workflow. Behind the scenes, agents use tool calling to fetch up to date information, optimizing their decision, and even break down the task into smaller subtasks automatically. How you structure your agent matters a lot. Broadly, there are two approaches. The first is manager structure, where there's a central manager coordinating everything. This manager assigns a task to specialized agents and ensure things stay on track. Interestingly, this manager could either be a human as well, guiding the process, or another AI agent as well, acting as a coordinator. The second approach is decentralized structure, where agents work more like peers. There's no central manager here. Instead, agents pass tasks to each other based on their expertise. Each agent knows what it is good at and steps it needs to perform. One big advantage of using multiple agents is reliability. Agents can review each other's work and provide feedback and catch mistakes, which improves overall accuracy. That said, it is usually best to start simple. Begin with a single agent, fully utilize its capability. In many cases, one well designed agent with right tools is enough to handle even more complex workflows. You should consider adding more agents when the tasks become more complex, when the agent struggles with the instructions, or when specialization can clearly improve performance. Breaking work into smaller, well defined responsibilities often make the system more scalable and easier to manage in the long run.